Hello, how y'all doing today? My name is Bernie Thompson, and today we're here to take a look at this little Mercedes-Benz. This Mercedes is a 1997 E320, and this vehicle was brought over here from a German specialty shop, and apparently this vehicle has a misfire on number 6 cylinder, and they believe that it has a mechanical failure in the engine, and they know I'm real good with compression work, so they want me to check this cylinder for compression. Apparently the misfire gets worse when it gets hot, so that obviously to them implies that this has a mechanical failure. No, we don't believe any of that. I only believe in data. So the first thing I want to do is start collecting some data. So let's get a scan tool on this car and start collecting the basic data that we need to properly diagnose this vehicle. Okay guys, I got the scan tool up, got some data. Okay, so we're not switching back and forth between rich and lean, and it shows we have a control problem. We don't have long-term or total trim problems. The trims are okay right now. The engine is still cool. We just started it. We have low vacuum, and we have some codes. So let's see what the codes are. Okay, we have a code for misfire on cylinder 5. We have misfire on cylinder 6, misfire on cylinder 4. Now the shop that's had this has been working on cylinder 6. So I'm not sure what's all going on there. And we have some other assorted codes here. An intake air temperature. I mean, I don't know what they've unplugged trying to fix this, so you don't get too caught up. When you're me and you go to these shops, they've unplugged all kinds of things and set codes. Now I've got an evap code, a secondary injection problem. I don't think that those are going to be any problem. Now the fuel trim problem, it says malfunction bank 1, but I don't necessarily see a fuel trim control problem right now, but the car's not missing right now either. And basically I'm staying lean. I'm way lean. I'm not switching back and forth. So let's look at some data. Okay, so the long-term trim is -6. Short-term I don't really have any, so the fuel control is okay right now. But again, we're not hot, and this problem misses when it's hot, and I'm not hot right now. We're going to need to warm it up and get it to miss, but I want to be really careful. I want to be testing up for what cylinder's misfiring before I get it too warm and it starts misfiring to where it will shut an injector off. Always be careful. Always be careful on a lot of these cars, because if they get a misfire, they'll shut the injector off, and then you'll get all confused thinking that something's wrong with the ECM. So we don't want to get it too hot till we start checking for a misfire. Okay, so the trims look okay right now. Now the low vacuum worries me a little bit, so what I want to do is I want to go and I want to get the mass error PID. Okay, the intake air temperature is reading, and I've got about the right temperature being read by the, so it is reading now. I have a code for that, but I think they were just unplugging stuff. Now what I'm really interested in here is the mass air. So the mass air grams, just let it idle. They're actually overreading at 5.4 grams. I'd expect this to be about 335. I think there's a 3.3 engine, 3.3 liters, so this should be right around 3.5, 3.335. This seems like I'm overreading the air, but if I'm lean and I'm not adding fuel, I was just worried about the low vacuum, like if I had a vacuum leak. But if I had a vacuum leak, I would have lower airflow, not higher airflow. So I don't want to chase any of this data right now, guys. Okay, the most important thing for me to know right now is what cylinder is missing. Which one of these is missing? They've been working on 6, but I don't really care what they did. If they could have fixed the car, I wouldn't be working on it. Whenever you're working on a misfire and that's what you're trying to find, focus on what cylinder is missing so we can figure it out. So the first thing I want to do is get a misfire detector on this car where I can figure out what cylinder or cylinders are missing. So let's go ahead and get that system installed. Okay guys, I had to go looking to find the battery. It wasn't in the trunk, it's under the seat like a lot of German cars. But we got to have the ground connected at the negative post on the battery when we do testing. So I want to get the scope's ground set up here so as we do the testing we know we're correct. Okay guys, in order to find this misfire, I'm going to use this Venturi assembly with a pressure sensor. Now what happens is when this car misfires, the air rushes, it then rushes back into this exhaust pipe, and that means I have a high volume flow go through this Venturi and it makes a pressure drop from the Benelli effect. Then what that does is I'm sensing that pressure drop, the drop from this tube, and now I'm not looking for pressure pulsation, but I'm looking for a volume change. This changes everything because now I can find volume and it's way more accurate. So what we're going to do is we're going to get this guy in the tailpipe, and now I need to go set up a trigger. Okay, in order to find this misfire, I'm going to use automated software. I'm going to use the Intelligent Engine Analyzer. So we need to go over to the configuration table. Okay, we want to pick misfire. I want to find Mercedes-Benz. So we have the right firing order, 1536-24, and our trigger is set on 1. The first thing I need to do is I need to prove this clamp, which direction this clamp goes. These pickups that go around a wire will have rivets on them, and the rivets are supposed to face the plug. But when you have a waste fire system, you could have the polarity go either way. So I don't know which way the polarity goes. So I want to show you how you attach these to figure out your polarity. So let me start this up. Okay, the way you set these clamps up is by looking at the screen. See how big it is? Now that's the rivets are facing that spark plug. Now do you see how small the reading is? That's the wrong way, so we're reading the wrong polarity. So on this one, the rivets are going to face the spark plugs, and that's going to give me the right polarity right there. So now we want to go over to misfire. We need to set this up for a DIS. Okay, now it's just starting to get warm to where we're getting some misses here. And we can see the cylinder 5 is my misfire. So we're missing on 5. C5. Now they've been working on cylinder 6, not 5. So it's imperative that we know what cylinder is misfiring. What are we working on? They've worked on 6 this whole time, but my miss somehow is on 5. Now, we need to shut the car off, because if you guys let this run and it keeps missing, it will shut the injector off, and if the injector shuts down, and that's a strategy. But I just worked on a car yesterday, a Honda, that they brought over here, and they thought the ECM was bad because it wasn't firing the injector. But it was the ignition coil was bad. And the ignition coil was bad, and so it was missing, so the injector is shut down to protect the cat. That's strategy, guys. So this car can shut off the injectors. So we want to be a little careful of that. Now let's go look over here real quick. I want to show you something. These larger strikes down, these are misfires. So do you see how that's dropping way down? Every time you see these big drops right here, that missed and that's 5 missing. Okay, so that's what we're looking for is there. So now is what I want to do is we want to go ahead and we want to shut the car off. I don't want to get it to miss too much. Okay guys, is what I want to do is I want to look at the ignition to try to figure out what's going on with this misfire. So I put E-cops on the coils. Now you can see that these are waste spark coils. So I'm sparking 2 cylinders at the same time, one with the coil direct and then one with a wire. And we can also see it looks like all the coils and the ignition wires have been replaced already on this vehicle. Okay, so I've got this one, and this is going to be 2 and 5. This one's going to be 3 and 4, and this one back here is going to be 6 and 1. And those are all on the same crank plane, so I can fire the 2 that will be on top dead center at the same time, and that's a typical waste spark system. I left my ignition trigger on 1, so we know it's working and we know we're on 1. Now let's go get some data and see if we can see what's going on with these ignition waveforms. Okay, let me go ahead and show you how I set the scope up. I set up 20 amps, that means it's a 10 amplifier. So on all the E-cops on channel 1 yellow, channel 3 green, and channel 4 blue, I picked 20 amps. That's 10-time multiplier, it'll make it bigger. I inverted all the channels and I zeroed them. Now let's see what these ignition waveforms will teach us about this vehicle. Okay, so here's our waveforms, so let's get a quick look at these and see what's going on. Okay, so the yellow one is really lean. And if you just look at these, the yellow ones are all higher in their spiking capability. But right here you can see where the burn I fired and then my burn is coming up like that. That's a lean cylinder. See how this is coming up just steep and high, way higher than this one? This is a lean cylinder. So now, let's figure out which one it is. Okay, so I want to show you guys something. This is my trigger, and that's the fire on compression, and that's the fire on exhaust, and that's compression. The bigger one is going to be a compression strike. So we want to go from that to that. Now if the one in the middle that's on exhaust is as big as these, you have a secondary problem. In other words, a secondary ignition problem is indicated. Okay, so that is cylinder 5 that's really lean. That's 153,624, and we can see that this guy is really lean, and that's 5, okay? So 5 repeatedly is lean, and we can see again it's really lean over here. And that's really lean. At idle, for it to come up that high, for it to come up like that, that's a really lean cylinder on 5. So 5 is lean for sure, and that's causing a misfire. Now what I need to be really careful of right now is this computer hasn't shut that injector off yet. Because if the injector got shut down, I'm going to have a problem, and it will give me a false lean. So I need to get into the injector, and we need to see what's going on with that injector. So let's go ahead and do that. Okay. I'm in the number 5 injector with channel 5 white and channel 6 purple, so we can see what's going on with that injector. Okay, I've got the injector set up on channel 5 white and 6 purple. Let's see what we've got. Okay guys, we don't have anything firing on those right now. There's nothing there. So the injector is not being pulled down. So that could be why I'm lean. That is why I'm lean. Okay, so I don't got any injectors firing. Now that's going to cause it to be lean on this cylinder, but that is an ECM strategy. So now is what I need to do, is we need to clear the codes to see if we can get this firing so we can check that. Okay, so I've got the codes cleared. Okay, so now we've got the injector firing. We can see it in purple. So right away, let's just look at the ignition. And now we can see it's not so lean either. But now we need to try to figure out, now that it's firing again, we need to look at some of this data. So I've got a ramp at the bottom, so I've got current flowing through the injector. I've got some distance between the towers, and I've got a hump, so the injector is opening and it looks okay. So now, let's look at some of these. Now that's a lean cylinder right there, and that's on, and I'm still firing the injector. We can see the injector is firing the whole time here. That's a pretty lean cylinder still. And that the yellow is on 5. That's not so lean there. That's again, that's lean, it's showing it's lean. That is a lean cylinder, guys, right there. That's lean, and the injector is firing. So the cylinder is missing because it's lean. So the injector electrically is firing okay, but the cylinder is lean. We can just look at some of these, and we look at where we got higher spikes here. That one's not so lean. It's a little lean, but it's not as lean as some of these other ones. Some of these are really, really lean. Okay, so I moved the trigger, so the trigger will now indicate 5. So now what I want to do, I want to set our trigger up on 2. So now we're just seeing 5 fire, and we can see every now and then this is going to spike way up. Like, look at how it's going lean here. When it spikes way high, that's lean, okay? Now I want to make sure I've still got that injector firing. and it's not. The injector stopped because so the strategy has already shut it off. So in order to go forward right now, I'm going to need to clear the codes again. Always be careful, because if the strategy is shutting it off, it's going to show lean. And we can't, we know that the cylinder's lean because we had the injector firing and we see lean. But I need to go ahead and I'm going to have to clear the codes again so we can get that injector enabled again, so we can try to figure out what's wrong with this cylinder. Okay, we've got those codes cleared. Okay, so we can see the purple. We're firing the injector again. So we're clearly firing the injector, and we clearly have a super lean cylinder there. Do you see how high it came up? And we know we're on 5 because you can see the red trigger behind it. And I've got that on cylinder 5. So that is lean. That cylinder is lean, and that's why we're missing, is because of a lean cylinder. But we can clearly see that the injector is firing. We have a bump, so it opened. We have some width. Always look real carefully at how wide the towers are. If they're really narrow, it shows I have a current problem. And we're also clipping towards 70, 73 volts, so that's good. And then you want to look down here, and you want to make sure that this bottom ramps up. See how it starts and it starts to ramp? That shows that I've got current going through that injector. So the injector has current. It's not an electrical problem. This has some type of a flow problem, I believe. But clearly we have a very lean cylinder here. And the lean is what's causing it to miss, and then the injectors are getting shut off. So we can see it's lean right there. That's a lean cylinder. See how it's just taking up? And we'll mark that with the cursors so we can see it. We can see that right there is where it's lean. That's a lean cylinder. And the injector's fired. So the injectors were firing there, and we still have a very, very lean cylinder. So we have a lean cylinder, and that's what's causing it. But I want to make sure, I gotta make sure you guys understand this, because a good shop brought a car in yesterday, and it was a Honda, and the same problem, but they had condemned the ECM, and it's not the ECM, it's a strategy. So as soon as this car misses enough, it's going to shut the injector off, and man, then you just get confused because there's no injector and you got to miss, so you think that's the cause of the problem. That's not the cause, that's an effect. It's just an effect. But we do have a lean cylinder on this car with the injector present. Well, let's see if we still have that injector firing. The injectors have already shut off. See that? I got no purple. They're off already. Okay, so we know we've got a lean cylinder on the car, so now we're going to need to start to look at why it's lean. Okay, so I got a pressure gauge attached to the fuel rail. And so we're attached to the fuel rail so we can watch the pressure. And then I'm in injector number 1 and injector number 5, and we're going to pulse these two injectors, and we're going to see what the difference in pressure drop is. You're only allowed 1 pound of pressure drop difference between injectors. So that'll give us a real good idea if 5 has a problem with that injector or not. Okay, we're going to use the oscilloscope under outputs, and we're going to be able to pull the injector down like we see right here, and this is going to pulse it. So this is my pulse setup right here, and then we'll activate it once we charge the rail, and we'll watch the rail on each injector as it drops. Okay, you can see that I've just got the lead going to the purple wire right here for number 1, and when we move it, we're just going to move this lead. This is the pull down lead, and we're going to come over and we're going to get on number 1 there, and the scope is going to pull that down through this system right here, which is pull down out through the scope. So this lead comes over here, and we're using it to pull it down to ground. Okay, now we're going to do cylinder 1. We drop to about 19 pounds, 20 pounds, okay. Okay, now we're going to do cylinder 5. Okay, we only dropped to about 23 pounds. That's 3 to 4 pounds difference than number 1. You're only allowed 1 pound difference. So that injector definitely has quite a bit lower flow on 5. Okay, guys. Is that one crazy diagnostics or what? Here, this came from basically dealer techs have been working on this. This is a German-only shop, and they could not find this misfire. They were sure that this misfire had something to do with the compression. So think about how happy the guy who owns this car is. He thought he needed a motor, and now all he needs is an injector. That's the difference between following data and guessing. Guessing gets you a motor, because obviously if it misfires when it warms up, that's more a motor problem. But let me explain what happens, guys. That injector is partially restricted, and we can clearly see that through the pressure drop. So what happens is when the cold start enrichment is on and I got a longer injector pulse, that injector will give me a combustible mixture. But when this car starts to warm up and the cold start enrichment comes off, and now we're just running on a warmed up engine, that injector is not on long enough to give me a combustible mixture, so I start to have a misfire from being lean. And you know, anytime you got one of these cars, especially one of these Mercedes or BMWs, where they cut the injector really, really fast, it makes the diagnosis extremely difficult. Because as soon as you think you're figuring out what's wrong, they've cut the injector again. So just be really careful of that strategy. Understand that many, many cars do it. It just seems that Mercedes and BMW kill the injector quicker than other cars. It makes it almost impossible sometimes to find what's really causing the miss, because right about the time you're about to see what's causing the miss, the ECM has cut the injector off again. So it can be a tough diagnosis. But guys, this isn't a tough diagnosis. It might be a tough diagnosis for a dealer tech because they know how to use scan tools. And they really don't know how to use all the equipment that I'm showing you here. That's why I want to show you these techniques. This is not a hard car to diagnose. If you follow the data and you have a data-driven plan, a diagnostic plan, you'll always be successful in your service base. Use a scope and start to win. Don't lose these battles, win these battles. A little bit different problem. It really is, I got to give you that, to where the injector is causing it to run fine when it's cold, and when it warms up, it doesn't run fine. But now we know what's wrong with it. It's obvious what caused the problem, and the cause is I got a restricted injector. And when you go together with the PC program, giving enriched fuel when it's cold, and I've got a little bit more on time, just enough more on time to where I can get a combustible mixture in the cylinder, it doesn't miss till it warms up and the enrichment comes off. It's not that difficult. If you guys use scopes, you too will be successful in your service base.